All right, so last time we were in the middle of the Mayans, well, almost at the end of the Mayans. Just a reminder, a few things about the Mayans. They had a base 20, modified base 20 system. They had dots and lines and this shell sort of shape. It was written vertically with the smallest number on the bottom, the smallest place value on the bottom, largest place value on the top. And they repeat some symbols when they want bigger numbers within that place value. When we did the problems where we turned their digits into ours, what operation do we use? Multiplication, right? And we drew these blue lines to indicate where the place value had to change. And then if we both go from their system, our system into theirs, we use division. Right, Brian? Good. All right, so, and we were doing that based on what powers, or what the place values were, and these are based on powers of 20. Are we remembering that? And these were the numbers. My pen broke. All right, they were based on the numbers 1, my stylus, the 1 and the 20, the 3,600, 7,200, the next one was 144,000, and so forth. All right, so this is the one we're on. So we're looking at the number 58,000, and what we want to do is to divide it by something that's as large as possible, but not larger than this number, of the ones that are in the place values that we just listed over here. So we can actually divide this one by 7,200. So we're going to put our 7,200 on the outside. We did this division scaffolding last time. And it's going to play into what we need actually to do in section 4.4, which is why I wanted to show it to you now. So grab your calculator if you have it with you. Don't everybody reach for your calculator at once. Lynn has one. I see it. All right, so what we're going to do is you're just going to tell your calculator to divide 58,532 by 7,200. And I want the whole number part. 8. All right. And then you can ask your calculator to do 8 times 7,200.
57,600.
To threaten it, I'm going to go get the IT guy, and he's going to watch us do the problems so that he can see what's messing up if it keeps messing up. All right, subtract. What's 58,532 minus 57,600? Say for me louder, Alex. 932. All right, so what is our next place value? 360. So let's divide by 360. So how many times does 360 go into 932? Twice, okay. And then 2 times 360 is 720. And we subtract 212. And then what are we going to divide by? 20. How many times will 20 go into 212? 10. 10 times 20? 200, no calculator needed, right? And we subtract and we get 12. And I know it looks really funny. You'll see more of why we're doing it later, but we're going to do our last one, which is always to do the last place value, which is the place value of 1. And it's always the number 12 at the end. Okay? Okay, we're going to take the 8 because you can see it anyway. How do you write an 8 in Mayan? 3 dots with a line underneath. Does everybody remember that from last time? Yeah, I know. All right, so now we see there's the 3 dots in the line. How do I write the number 2? 2 dots. How do I write the number 10? 2 lines. Whoa. Let's use a line tool. Or at least this one. 2 lines. How to write the number 12? 2 dots, 2 lines. Okay, now, first of all, this is perfectly correct. Everything's fine. There's nothing wrong with this from the perspective of you're in contemporary math and you're writing me the number that this represents, okay? So nothing to concern yourselves with. However, there is something about this that's concerning from a very practical perspective. Do you know what it is?
You would think that that would be 12 twice.
Yes, that's what that looks like, right? It looks like I have an 8 here, a 12 here, and a 12 here, doesn't it? And there's nothing in their system that fixes that. I don't have any way, like in our system we can do things like with commas and we have 0 placeholders and things like that. And while they have a 0 placeholder, it would fix some of the things that the Babylonians had going on wrong. It doesn't fix this because there's no zeros anywhere, right? It's just that the dots and the lines don't happen to be within the same place value. They're in successive place values, and so they look like they could all go together. So again, there's a reason we don't use Mayan, and this would certainly be one of those reasons, right? All right.